Hello and welcome to today's SGI webinar. My name is Dan Marks. I'm SGI's Director of Content Development, and I'll moderate today's program. Before we get started, I'd like to let you know our webinar system allows you to ask questions through your computer. So if you have questions at any time, even now, feel free to submit them, and we'll get to them at the end of the formal presentation. Before we get started, I'd like to introduce Peter Pretzer from Fujifilm. He's got a great presentation put together. So Peter, welcome.
Well, thanks, Dan. I'm here today to talk about color management and what we can do as our markets are changing now. And we're going to talk about cross-market color alignment. And before we get into this, I want to just say a little bit about what I do here at Fujifilm. I'm a product development manager for ColorPath Solutions, which is Fujifilm's suite of color management solutions. These deal with plate curves. We do ICC and device link profiles. We do some ink optimization, some brand color optimization, and some other things. I want to talk about how the market's changing today and what you might need to know in the state of the art as far as it concerns color management. I'm going to try to keep this not as a commercial. I'm not going to be mentioning specific solutions, but I'm going to try and keep it general so you guys can get an idea of what is happening in the market today and what's coming down the pike. So let's talk a little bit about the market. These are numbers from 2016 on the right-hand side. The Bureau of Labor Statistics has decided to stop tracking the printing industry because, and I'm quoting, some industries no longer have sufficient samples to be estimated and published separately and were discontinued.
Hey, Peter.
Yep.
We're seeing the picture of the sand dune.
Oh, I'm sorry.
No
All right. It's
Okay, bear with us for a moment.
Sorry about this, everyone.
Is your screen frozen, or is it?
No, it's showing that it's there, but I'm seeing okay,
let's try that. Now I'm seeing the.
Yeah.
There we go.
All right, let's pick up from where we left off. So these are numbers from 2016 that you see on the right. These are market numbers. Okay. Basically, the market has shrunk enough that the U.S. Bureau of Labor Statistics has stopped publishing employment figures for printing and related support activities. There's a decline in employment in these groups between 2010 and 2018 of about 44,000 jobs, or approximately 10%. So, however, economists say that it's incorrect to assume that this trend is entirely due to the industry becoming insignificant. Andrew Paparazzi, the chief economist at SGIA, says that the numbers don't tell the true story. He says, in fact, that we're actually expanding and becoming even more important to the American economy. The decline in employment numbers are more the result of ongoing productivity advancements and not due to a decline in demand. And this is proven by numbers that show that sales per employee are actually up almost 25%. So our productivity is raised even though the market is shrinking a bit. The industry also, according to forecasts, was supposed to grow again for the first time in about 11 years. PIA forecasted a 1 to 2% growth in revenues for 2019. Now, that remains to be seen, but opportunities are there for those who are in a position to capitalize on this type of work. This is according to marketingcharts.com, a little bit later, a month later data, and it shows we're seeing growth in some other areas of ad spending, and again, print is down about 9.5%. This is due to a State of the Industry report for print economics and management, again, about the same time as the previous two slides, but it shows where printers plan to make their investments in capital equipment and new technology. So the point of this is that we're trying to make a case for inkjet as a kind of a sea change in technology being used for printing. And with all that being said, I'm here to talk about the state of the color alignment for various printing conditions, technologies, and markets, particularly the wide format inkjet market. Let me just read what this says here. The production inkjet market is entering its 12th year with no retirements of inkjet presses in sight. The technology has lived up to its promise of upgradability, and these heavy machines have lived up to their projected durability. With virtually no retirements, the installed base is growing at rates well beyond other similar age digital print markets. So if we combine both the growing installed base plus the growing monthly print volume, we get a growth curve that we haven't seen before in print markets very often. So we have some data that do show that things are growing, but it's specifically inkjet technology. And this is one observation, that the customers who install toner or roll-to-roll devices are able to move into that technology more quickly. I also want to show these are some new premium and non-traditional materials that you can see happening in inkjet. These are some that we've done here at Fujifilm, but you can see we've got UV fabrics that have sprung up in the last couple of years and are pretty ubiquitous. We've got newer multi-layer day and night backlit. We're seeing this replacing a lot of signage in public spaces. So this might have replaced some fabric or paper type print. Now we're printing on some other substrates. We're seeing more dark colored and metallic substrates. Some custom interior design elements you can see here, wall coverings, things that basically will show off a commercial space. We see a lot of that. Packaging, of course, but we're seeing more and more of that in inkjet. And then again, structural design for displays. So things that are going to hold products or try to draw somebody into a commercial space. So these are just some ideas of what is we're seeing more and more in inkjet, some of the opportunities that are out there, even though a traditional offset is declining. So let's talk about the state of the industry for color management. I'm going to start from a commercial perspective because that's really where most of us are and what we understand, and I'll show what's different as it pertains to wide format and other inkjet devices. So we all know about G7. I just want to cover this for those who maybe are here to learn for the first time, but G7 is a process that allows us to align devices based on gray balance. It is substrate relative, meaning I'm going to calculate gray balance based on the color of the substrate I'm printing on, but the whole idea is to provide a shared neutral appearance between and among printing technologies. If we think back to how we used to do it for offset commercial work, we would base color on density and dot gain. That does not guarantee that color is going to look alike. We can nail the same numbers that way, but we're lucky if we achieve a similar visual look. If we do it on gray balance and tonal range, we tend to be much more successful. So here's some other examples of that. We're showing here on the top row, we're seeing the raw spaces of something before it's been calibrated. Once we align it to G7 on the bottom row, we see that we've got, again, that consistent, similar visual, near neutral alignment. So this does a couple of things. Works across multiple printing technologies, multiple printing conditions, meaning I can do this from not only on my own site, but across geography, different geographical sites. It makes things predictable, repeatable, and accurate. So if I do deviate from color, I can get back to where I started from pretty quickly. And it allows me to predict pretty accurately with proofing systems how I'm going to print on whatever the device that happens to be. So the process has been and continues to be, we print a 300 patch chart on whatever device that we want to align. Typically, we're working with ink being laid on, for process colored inks being laid on a substrate. We measure that chart. We use some specific software to calculate those curves. We could also do this with some graph paper that's been designed to calculate this. We plug in the curves in our front end, we rerun the job, and we remeasure to confirm the results. And typically, we can get there within 1 or 2 press runs. You see here what some of the curve data might look like that comes out of one of these systems that's designed to do this, plugged back into the front end. So that's what we've traditionally done for offset work. We see this being required for required by many print buyers. You can see here an example of some of the print buyers and brand owners that are requiring G7, that their print providers be qualified as master G7 printers. So we don't just stop at aligning the device based on gray balance. We also use what we call characterized reference print conditions. In a CRPC, or characterized reference print condition, there are 7 of them. These have been designated as international standards by ISO 15339, which was ratified in 2015. And you can see here what the 7 characterized reference print conditions, or CRPCs, are. They're based on cold set news, heat set news, a premium uncoded stock, a super calendared stock, publication base, and premium coded, and then there's a universal extra large that is based on an average of some digital devices. So these 7 devices, or these 7 print conditions, we should be able to take an inkjet device and align it to these through the use of profiles. This shows what they look like. So here's 1 through 7. You can see they are very well aligned color-wise, a similar visual look. The only difference is the amount of saturation that each of those substrates is able to provide. They've all been G7 aligned, and in so doing, we can see here that with that and with the aims of each of those, what the recommended densities might be for our solid aims and overprints, we also line these up on hue angles. So again, that accounts for a similar visual look. And it also makes for a great basis for aligning any device, whether that's inkjet, offset, flexo, you name it, we can get there. So we've got a similar visual look for all of those, regardless of the printing technology. Here they are by volume of color space. So you can see here the aims, the pointed corners out here. These are the solids and overprints. So I've got my cyan, I've got my yellow, I've got my magenta, red, green, and blue. And again, they all line up pretty well, and they give me a nice way to predict how I'm going to print and give me a decent target to aim my devices to. Now, how does this apply to wide format? Well, there's a few caveats here we've got to look out for. One of those being is that the CRPCs don't all line up exactly to make a good target for an inkjet device. The inkjet devices, inks, tend to be a little bit different in hue and volume capabilities from those of offset, flexo, and other previous technologies. So the different shaped color spaces aren't conducive in a lot of cases to lining these up. And as you can see here, I've tried to show that the center color space that you see is a typical wide format inkjet device. And if we try and match it to the closest CRPC, well, you can see in yellow, we have to dumb it all the way down to CRPC 3. And that's right up here. If we get to our purples and dark blues down here, we can see that we can extend that all the way out to CRPC 7 or larger. So we've got a pretty big discrepancy there between which of the CRPs we should run to. So I'm kind of hung if I do and hung if I don't here. In this case, the CRPC is not a real good way to go. So we've got to think about some other ways to do this. Here again, we're showing the yellow and the blue. So the yellow is a good fit for a CRPC3, and the blue and violet, we can go all the way up to 6 or 7. And again, not a good fit. I can't pick one or the other. I'm suffering. I'm going to chop off the tonal range of the yellow if I go with the purple, and I'm going to clip the purple if I go with the yellow. So what we do is we create ICC profiles for the device itself. The first thing we need to do on an inkjet device is set the ink limits. I've got to run an ink chart that tells me how much ink I can actually lay down on the device. And I also have to determine the solid ink density for that particular device, meaning how much ink can I lay down once I've figured out the total. Now how much can I run to get the most productivity out of that device? Typically, if I increase the solid ink density on an inkjet device, I'm actually slowing it down. So I'm not going to get as many beds per hour. And that can have a huge effect on my productivity. So I've got to find that happy medium of what is the proper solid ink density for a job, or at least know how many beds I'm capable of creating and producing without killing my budget. So that's the first thing we need to do. Second thing we need to do is we print an IT874 chart. I'm going to recommend an IT874 chart because this produces data that is portable, meaning I can exchange this with, this is defined as an industry standard. The next one will be IT875, and I'm actually showing IT875 here. That's the next coming standard. So print the IT875 chart and then measure it with a strip reading spectrophotometer. And once I've got that data, I can plug that into my ICC profile software and create the destination profile for that particular device. That profile is a lookup table that says, here's how this device will print for this particular print condition. Some things I have to worry about or be concerned with when I am measuring is the measurement condition. So what is the mode that I'm measuring using my spectrophotometer? And today we want to have a device that can measure in an M1 mode. This mode is a newer method. It includes a UV, a specified UV amount, and spectral power distribution of a light source that simulates D50. It measures optically brightened substrates more accurately than a previous mode called M0. And this is required for international standards in the graphic arts marketplace, and for CGATS 21 in the US, and at the international level at ISO 15339 and 12647. So really all of the graphic arts standards are moving towards M1 as a measurement mode, and it measures the white point more accurately. Previous mode M0, we don't see this used much anymore. The spectral power, the UV is included, but it wasn't defined very well. So the problem was I would get a similar measurement if I had an optically brightened substrate versus something that was very neutral white point. I might have a difference of maybe 7, 8 delta E between those. If I measure an M0, it might show no difference, or maybe a difference of delta E of 1. So we've moved from M1 to M0. Some other modes that we might want to consider. M2, this is a straight UV cut mode. If the white point doesn't matter to me, and we might see this a lot in outdoor types of signage where I don't have to worry about it, I'm more concerned with speed. I cut my UV, and I don't worry about paper fluorescing at all. In daylight, it knocks it out. I use M2 mode. So I got a faster reading typically, and I'm cutting that UV as a factor. There's also one called M3, and this includes a polarization filter. And we use this where we're trying to measure while ink is still wet, or if we're printing on a highly reflective surface. So something that's pretty shiny, what happens is I might have, when I'm measuring, the light from the measuring, light source from the measuring device will bounce back up into the sensor, and I'm going to get some incorrect measurements here. So we're seeing M3 now as being valuable for measuring on a shiny surface like polystyrene, things like that. So you might want to use this in those cases. The other thing we have to worry about is the aperture size of the device. Typically in offset, we might be measuring a color bar on a press sheet, and the color bar might be using patches of 2 to 3 millimeters in size. In that case, we can go all the way down to about a 1.5 millimeter aperture on the measuring device. I can save a lot of room on my press sheet if I can keep that down and still get decent measurements. On an inkjet device, however, I might need to take a larger measurement. I might have to have a larger aperture, and this is mainly due to the roughness of the print on some of the inkjet devices. Now, this is becoming less of a factor, but there are also new devices coming out, new measuring devices that also allow me to measure M0, M1, M2, or M3 without having to change light sources. I can do it in a single measurement. Therefore, I've got a single device that can use all of these. And if I want to capture the best amount of data for M3, for example, measuring some specular highlight material, I want a wide format aperture, or a wider aperture. So devices are coming out today that have apertures of about 8 millimeter, and they're going to require a 14 millimeter patch size. So I've got a trade-off. I've got a device that's less expensive, where previously if I was doing offset work, inkjet work, maybe some other types of work, I might have had to have 3 different spectrophotometers on hand just to get accurate measurements. Now I might be able to do this all with a single inexpensive device, relatively inexpensive compared to the other 3, but I do have to worry about a wide format, a wider aperture here. So 8 millimeter aperture, 14 millimeter patch size. What does that mean? Well, it means I'm going to have a much larger chart to use. So maybe that IT874 or IT875 chart, which is 1,617 patches, maybe that's too big, doesn't fit the bed I'm trying to run, or maybe I'm running on a, I also want to run on a web press. In this case, maybe we can use a piece of software that uses a 500 or smaller patch chart. So I do have more options today with smaller charts, and I can get decent results with today's profiling software with those smaller charts. So again, larger aperture requires less patches, but larger chart size. So we can create those profiles and bring those into a simple ICC workflow. And the simplest of the ICC workflows is that I'm going to start with an RGB image. I'm going to convert it to the CMYK space of the device I'm printing on. That's called a destination profile. This is great for photo work. It pretty much guarantees that I'm going to reproduce that photo as accurately as I can on the device. So what the original photographer intended, if I haven't changed that RGB working space, I can now convert to the output space of the device I'm printing on. However, that doesn't guarantee that I have a similar visual look between devices or for other objects and tints in the job. So for photos, great, but if I've got tints, they may suffer. Also, I can't guarantee gray balance with this. I would need to G7 my device before I actually profile it. That would be a whole nother step, but that is doable and works well. The other thing this does is images can be converted in Photoshop and processed by most front ends with a simple ICC workflow. So I'm starting with an RGB image, I'm converting it to the CMYK space of the device, fairly simple. Next one we can consider is a CMYK space, simple ICC workflow. In this case, I start with a source or a target profile, such as Grackle or one of those CRPCs that we talked about, one of the 7, and now I convert that to the destination or device space. So in this case, the drawbacks here, my ink settings are limited because I'm going from CMYK to an LAB space back to CMYK. I can't control how much ink other than total area coverage for the most part. And my accuracy may leave room for improvement. I get what I get with this. Maybe I end up with a 3 delta E on average between what I intend and what the device can reproduce. The only way I can fix that is to go in and actually tweak edit the profile itself. And I need to know what I'm doing there. I need to have a tool specifically designed to do this as far as software goes. Not the most productive means of doing it. It also requires that the CMYK images that I'm separating or converting need to be separated to the appropriate working space. So start with my target being Grackle, and I go to the destination space. This is what's called if I look at all three of those, that's called a simple device link. And that happens inside most of today's front ends. And that leads us to the next type of workflow we can consider, and that's a device link workflow. So once again, we are starting with a source or target color space, and I'm converting it to the destination space. But a device link in this case, I can nail down my CMYK settings for it. So these can be precisely defined, and they allow for more options, such as applying GCR or ink optimization or other black handling. When I'm talking about other black handling, we have to consider what happens to black when we're color managing it. If I use a source or target profile like Grackle on a press, it looks nice and black. When I get it to a digital inkjet device, it might start to look a little dingy or brown compared to the actual black on that inkjet device. So what do I do now? Do I color manage everything, or do I color manage everything but leave my solid black alone? So that's one of the things we can do with a device link, is we can say color manage all the colors, but 100% black, let's keep that pure. The other thing we could do is keep the entire channel pure. So depending on the tools we have, we can tell it keep yellow pure, don't allow any little dots of cyan or magenta in there. Let's keep my 50% black tints pure. Maybe I've got a designer who used a 50-40-40 patch that's looking a little warm, and it's butting up against a 50% black patch, and it's nice and neutral. I see a difference there. If I can control the entire black channel, I can maybe fix a lot of those issues. So I've got a lot more things I can do with a device link workflow. The other thing I can do with this is automate a lot of these color changes that are taking place. So instead of doing these image by image in Photoshop, there are various front ends out there that will allow me to take a PDF in, color manage everything in the PDF. I can even do different things to different images within the PDF. I can have a PDF with mixed RGB and CMYK images, and I can have different things happen to those RGB images, how they tell it how to convert to CMYK. And other front ends, I'm limited. I don't have RGB and CMYK converting capabilities. It has to be one or the other. So these tools are coming out today and are available. So we're getting quite a bit of flexibility compared to what we have just a few years ago. I also want to talk about the importance of color conversion. So I don't know if you guys can see differences here on your monitors, but on the left-hand side, we're all familiar with this image, the musicians. This shows the original file already separated according to ISO compliance. Here's how it's supposed to look. But if I leave my settings in Photoshop as they come out of the box, let's say I download Photoshop, I install it on my computer, I use the default settings, the image on the right is what I come up with. So you can see some differences there, especially in the yellows and the vest on the woman on the left. If we were to print this out, we'd probably see some flesh tones that would flare up a little bit on the right-hand side. Some people might think, hey, that's an improvement, but it's different from what the original intent was. So we have to be careful of this. And I would urge folks out there to check what your Photoshop settings are, and if they are set to swap, you might be converting your images into a space that's smaller than what you can actually print. And what that'll do is cause the image to flare at the end. So here's a second instance of that, and maybe we can see in this case a little bit of differences a little bit easier, specifically in the red of the girl's shirt and in the magenta of the flowers. So on the left is the original intent of the file, how it's supposed to look. If I've converted that to swap and then run it at maybe a little bit higher CRPC, I see what happens. My red starts to, the tonal areas of the red start to fill in and things start to flare up. Again, maybe it looks better according to someone's opinion, but it's not accurate. So we really have to be careful with how we're converting our colors and how we're outputting these on the devices we're outputting. And again, just to show some numbers behind that backs up what's happening. So if I take this image and I take those color bars that are on the sides and compare them, the original compared to the incorrect or the flared up version, we're seeing delta E's as high as 6.5 with averages of about 5.25 just for that image alone. So in a world where a brand owner or a print buyer is going to specify delta E's of 2 or less, here we're seeing we're getting killed in our process colors even before we even look at brand colors. So something that might help fix that, so a problem with printing to CRPCs in that inkjet environment is that aside from also limiting your color space and having to worry about the conversion being correct, something's been considered called an exchange space. And on the right-hand side, this can be found on www.color.org, which is the website of ICC, the International Color Consortium. Look on the right-hand side, and you can see this new PRMG-based exchange profile for digital print. So this kind of eliminates a whole bunch of problems with converting to the various CRPCs, having to worry about what the final print condition is, how am I converting that image early on. This is really a consideration that designers should take into account, because this can solve a lot of problems. I'm not saying this is a panacea. It doesn't solve everything, but it can make things much easier as far as predicting how things will print. So what this includes or involves is, once I download that profile, and if I look at the gamut of it, you can see that it's a pretty huge space. And the idea is that it can contain pretty much anything that we can print today. Well, this is a couple years old, this profile, and of course things keep getting, the gamut of printable devices keeps getting larger and larger. Inside there you can see this is the largest gamut wide format inkjet device we have today, and it is pushing the boundaries already of PRMG V2 profile. So there is a task force working on enlarging this even further, but if you use this, you can get pretty decent results. And it works, it's primarily designed for a device link workflow, and it's primarily designed that if you have RGB images, if you're starting with CMYK and converting them to this space, we're already going to run into the problem that we just looked at before with unintended flare-ups. So if I've got an RGB image, I can convert it to this space, and then I can get decent results regardless of what I'm printing to. So here's an example of how this workflow might look. So it's designed for pure digital printing, and sometimes it's more important to use the full color gamut of that printer than it is to simulate, like we do with the CRPCs. So there's 3 ways to do this today. We can create, as we discussed, a printer-specific profile or device profile. We can use a conventional exchange color space, much like we're doing with the CRPCs. Or we can use this exchange space and convert to a larger space and then actually bring it down to the space of the device itself. So what this does is it guarantees that we have a similar visual look. It can guarantee that we have a nice neutral print if we apply this, because this PRMG profile has also been gray balanced. And we know we've got a similar visual look on whatever device we're printing it on. So this really fits a pure digital workflow, meaning inkjet, meaning wide format. It works great if we've got access to RGB images. All I have to worry about is have my designers converted to the correct CMYK space if they're doing that. If I'm the printer, if I know that these are done, I know that all I have to do is print these to the space on my properly calibrated device, and I'm printing as good as I possibly can. So some ways of testing this: you can use this this profile as an intermediate exchange space for CMYK. You convert your RGB to the profile using a perceptive or relative colorimetric with black point compensation. So you got to have tools that allow that, and you can convert it from that PMRG space down to the final CMYK output space, and then compare those. So works great for proofing. and it works great for the final device. Before we wrap up, one more thing here. We want to talk about brand colors. So we've talked about general color management for process color up until now. Brand colors, a lot of strides have been made here in the last year or two, and we're seeing these from various vendors. So what we had to do is each of the front ends had its own method for maintaining a spot color lookup table. And previously, these may not have been as accurate as they could have been on inkjet devices. And again, it depended on the front end and what license they might have had from Pantone, or how they converted these colors. But what we used to do is we would take the entire library, whether it's Pantone or some other brand color library, we'd push it through a profile, and we would get these results. So I'd have an LAB value, I'd push it through the profile, and it would yield the CMYK results for that particular device. Again, I get what I get. As we talked about, maybe an average delta E of 2.5 with just a profile. This is the same type of thing we'd end up here with a spot color lookup table. So what a few of us have figured out how to do is print out the entire library. Each swatch in the library gets its own patch and a color chart. In this case, we're printing it out, we're measuring it, and we are getting that entire library now printed and measured in about 30 minutes. And this is similar to how we do an optimized device link. We can actually optimize this by repeating the process, printing up the chart again, measuring it, minimizing the delta E, and we can now start to get, within a very short amount of time, the entire Pantone library, for example, within a delta E of 1, except for those colors that are outside of the gamut, of course. So the illustration on the right shows that, hey, the white line is the device space, the yellow is a comparative offset space, Grackle, for example, 2006, and all the dots you see, that's the entire Pantone library compared to those two spaces. So my inkjet device, in this case, is going to give me a lot more chances to nail that spot color, that brand color. And if it's in gamut, if we're optimizing it properly, today we can pretty much guarantee that those in gamut colors are going to be reliably below a delta E of 1. And typically they're down around a tenth or 2 of a delta E compared to the actual target. So very accurate, very fast, very productive. And this also means we can predict those colors in advance. So I can get a decent prediction beforehand of the entire library in just a few minutes. And now I don't have to go to press and spend a lot of time tweaking. I don't have to stop those expensive devices from producing all day just to try and tweak a color. A single color might have taken an hour or two to tweak. We've got all 1,800 odd Pantones now within 30 minutes. So that's the state of the art today. And now we'll open it up for questions.
Okay, Peter, I know some of this work is really working to sort of push the problem upstream, where printing companies are tending to their color challenges before they become problems for their customers. Are there any specific examples you could share in terms of how a company has used this to communicate better with customers?
Specifically, I would say that the exchange space is one of those. So we've simplified this for designers. So for example, we talked about if I use the presets or the default settings in Photoshop and I start converting images from RGB to CMYK, the default setting is swap. It's a smaller space than what I may be ultimately printing on, especially with inkjet. Mm-hmm. And I'm not going to get a decent result. If I use that exchange space, I've completely eliminated that issue.
Okay, very good. And I know you mentioned, are there any sort of coming standards or coming major changes in the color management field that people need to be aware of?
That exchange space is one, and as I mentioned, we are at this point the PRMG profile is published. We're at work as we speak to expand that to make it even larger. Should yield similar results, but also, any images you have that have been converted to that shouldn't be destroyed. They're still going to be valid. Some other things, we're tightening up some of the pass-fail, at least in the U.S. In Europe, the pass-fail for a proof is a little bit wider than it is in the U.S., so we're tightening that up in the U.S.
Okay.
And we expect to see, as of October 1st, as of today, we've gone from a delta E of 3 in the paper white point to 1.5, so just for example. So,
wow. That is a significant tightening.
Yeah, and again, that's the paper white point. So what it means is that it's kind of forcing proof providers to provide a proof on a white point that is closer to how they're going to print it.
Okay. 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 Well, we're at the end of our time here. So thanks very much, Peter, for the presentation today, and thanks to those of you who joined us today. We hope you found the presentation to be informative. But as you know, registration is open for Printing United. It's October 23rd through 25th in Dallas, Texas. The huge expo floor is completely sold out, and registrations are running in hot right now. So if you haven't made plans to get yourself to Dallas, do that right now, and we will see you there. And we hope to see you online again soon. Have a great day.
Thanks, everyone.